Okay, class, let's start the last unit. Polymer synthesis. Here it is proposed to briefly discuss laboratory synthesis of a few polymers in order to get the feel of handling them. The experimental methods given in the forthcoming sections are preparatory and not meant for kinetic studies. The latter calls for rigorous control on the ingredient purity and polymerization conditions, which are beyond the scope of this book. So we are only going to see the preparatory experimental methods and not the ones which include the kinetic study. The experimental techniques are outlined essentially by way of guidelines. Okay, by way of guidelines. It must be stressed that many of the chemicals are toxic, corrosive, or obnoxious and should be handled with extreme care. We all know some chemicals can cause burns, irritation to the eyes, so which are very harmful. So they should be handled with extreme care. Avoiding direct contact with skin, eyes, etc. Inhalation of vapors should be minimized, and wherever possible, experiments should be carried out in fume hoods. Necessarily protective appliances such as hand gloves. Yeah, it is always advised that you should use hand gloves while doing the experiments. Safety spectacles, face shields, overcoat, etc. So in our college you are already wearing the apron, which is nothing but a overcoat, should be used. Many of the solvents are highly inflammable. Okay, so they can also catch fire very easily and should be handled appropriately. Peroxide initiators, being shock and thermal sensitive, may lead to explosions and should therefore be handled with utmost care. So the peroxide initiator have this shock and thermal sensitivity. Because of that, they can lead to explosion, so you should handle them with utmost care. Polymerization required reactions are exothermic and can get out of control. Like I gave you the example of bulk polymerization, sometimes it's exothermic and it can lead to explosion, leading to a fire or an explosion. All polymerization reactions should be conducted behind a laboratory safety screen. Before starting an experiment, one should acquaint oneself with potential hazards associated with the experiments and with appropriate precautionary measures to be adopted and observed. So this is an ideal condition of doing the experiments. We don't follow these many restrictions and precautionary measures, but some of them we do follow. Okay. Then monomer purification. Unsaturated monomers, vinyl monomers, are highly reactive and can polymerize during transport or storage. So you see these monomers are unsaturated, means they are CH2 double bond CHCl vinyl monomers. So double bond means unsaturation and they are highly reactive, and during transportation, due to the shock and thermal sensitivity, they can start the polymerization. So to avoid such polymerization, they are transported and stored in an inhibited conditions. Inhibitors such as hydroquinone or tertiary butyl catechol are used for this purpose. So inhibitors are the substances which does not let the monomers to polymerize. Inhibitors will have to be inhibited monomers will have to be freed of inhibitors, as it may not be possible to initiate polymerization otherwise. So they have a disadvantage also, that when you actually want to start the polymerization, you have to free the monomers from the inhibitors. Vinyl monomers are purified or freed of inhibitors either by washing away the inhibitor with dilute alkali or by the distillation of monomers, the latter being done carefully to avoid polymerization due to excess heating. So distillation is actually done carefully to avoid polymerization due to excess heating. Otherwise, dilute alkali is enough. Distillation under a reduced pressure helps in overcoming this problem. In the washing process, the monomer is taken in a separating funnel and is shaken with 5% solution of potassium hydroxide KOH in water. This is the dilute alkali system. This method is useful in the case of water insoluble monomers. The inhibitor reacts with alkali and the reaction product, being water soluble, comes out of the monomer phase and can be removed along with aqueous phase. On allowing to stand after through shaking, the monomer and alkali solution separates. The alkali solution is removed by washing with alkalis repeated several times. So separating funnel is nothing but you must have used it in the physical chemistry lab. It is having this knob which separates the two solution. So if two liquids are immiscible, you let the first liquid to pass and then stop the knob when that layer is gone to the other side. So separating funnel you can check on the internet also, you'll get it. In many cases the alkaline solution of the reaction product is colored and washing can be stopped when no more coloration of the aqueous phase remains. The monomer is then washed with distilled water to remove the alkali traces. It can then be dried using suitable drying agents such as calcium chloride, sodium sulfate, sodium bicarbonate or phosphorus pentoxide, all anhydrous. When monomers are needed for suspension or emulsion, they need not be dried after washing with water. So different polymerization technique, different are the ways you have to adopt. Saturated monomers containing functional groups used for step polymerization reaction should be purified to render them free of non-functional and monofunctional impurities. So in the third year you will learn what are the monomeric ingredients in final polymeric composition. There are impurities and additives in compound, so you have to know them, but just this is for your own knowledge, you can remember this much. No generalized scheme can be given for this purpose, and the procedure varies from one monomer to another depending on their chemical nature. While carrying out the experiment described hereafter, it should be ensured that the monomers are purified prior to use and that the chemicals and solvent are of technical grade or reagent grade. So these are the basic norms which you have to follow. So today we have seen two topics, monomer purification and polymer synthesis. Read it again and again to understand it better. That will help you. And we are the most intelligent batch in polymer technology and all of LIT. Actually the word intelligent is not enough to describe how intelligent we are. So start reading, get a hold on the subject.